Welcome back to another video with Hashtag Tutoring. Today we are going to be looking at function notations, and then we're going to go through different types of functions that we have. All right, for sometimes you get an equation where y is equals to ax plus 2, and this just means a function of y that depends on x, meaning that x is the only thing that is changing in the equation, and the rest of the terms remain the same or constant. Okay, sometimes you, instead of saying y of x, you can say f of x or g of x or even h of x. So depending on, whatever that you want to put there. All right, moving on to an example. If you have a function f of x is equals to 2x, and you are trying to determine the values of the function of x when x is changing, meaning x can be 1, can be 2, it can also be a plus 1 or any other thing. So the most important thing when you have a problem like this is to realize, or is to be able to do substitutions or to substitute. All right. For example, if x is 1, you replace x in the function as 1, and it'll give you 2. And if x is 2, you say f of 2 instead of f of x. Replace x by 2, you'll get 2 times 2 is equals to 4. But then what if x is a plus 1? Then what do? Again, you substitute. F of a plus 1 is equals to 2 times a plus 1 is equals to 2a plus 2. Okay, but then what if they say they give you a question where they're saying f of x plus a? All that you need to do is to replace f of x with 2x and plus a, and that's all you have. Okay, moving on to functions. We're going to be looking at linear function, which is a straight line defined by y is equals to m of x plus c, where m is your gradient, and m can be positive or negative because it depends on the b and a. If it's positive, your graph slopes up, and if it's negative, the graph slopes down, and if it's 0, the graph stays flat. And one other thing that you might want to look at is where the graph cuts the y-axis, which is when x is equals to 0. Okay, therefore your y will be c. Parabolic function, which can be given or expressed as y is equals to a of x squared plus bx plus c. A plays a very important role here because it defines the position of the shape of your graph. For example, if a is positive, the graph smiles up, and then when a is negative, the graph faces down. Okay, the next thing that it's also more important in the equation is the coefficient b, which defines or determines the level of symmetry and also the turning point of your graph. Okay, also lastly, we are looking at where the graph cuts the y-intercept or the y-axis. That's when x is equals to 0, therefore y becomes value of c. Thirdly, we are looking at your hyperbolic function, which is a little bit different because there's two shapes in it. It's expressed by y equals to a divided by x minus p plus q. A again plays a very, very important role again, because it defines the positioning of your graph. This is how it looks like when A is positive, and when it's negative, it's in the second and the fourth quadrant. All right. Also the asymptote. Asymptote just means that the graph will never cross or touch that line. So you have your vertical and your horizontal lines that the graph will never touch. Vertically, you are looking at the x, the term x minus p, where x is equals to p. X value, which is p, will define your vertical line, which is the vertical asymptote. And the horizontal is defined by a value of y to make it a horizontal line, which is y is equals to q, right? So moving on to number 4, again, we are looking at the intercept. So the x-intercept can be found by making y equals to 0, and the y-intercept make x is equals to 0. Moving on to exponential function. Excuse me, I meant exponential functions, which looks something like this, with the function y is equals to a to the exponent of x minus p plus q. P always translate your graph, your exponential graph. That means this can be to the left or to the right. Okay. For example, P can either be positive or negative. So if P is negative, your graph will shift to the right. And if P is positive, your graph shifts to the left. Okay. Also, the number 3rd thing that you need to also realize is the horizontal asymptote. And remember, when you talk about asymptote, you are talking about a line that the graph will never touch. So in this case, in an exponential function, the graph can decrease as much as it wants to, but it will never touch the asymptote line. Okay, so this is your horizontal asymptote, and also it translates your graph up and down. So if, for example, because your y is equals to q, which is your asymptote, if q is 5, if q is 0, the asymptote is x-axis, but if q is 5 or negative, then it goes up or down respectively. And with the 4th thing that you also want to look at is your intercept, which is similar to number 4 of the hyperbolic function.